Hi friends, today in this video we are going to be learning a little bit about derivatives of inverse trigonometric functions. Now what I feel, actually this is just my personal opinion, there's one thing why slightly don't prefer this Ncert mathematics textbook, especially this calculus part is they have compiled three different topics, three different topics in just one exercise. Like in 5.3 we have these inverse trigonometric functions, we have these implicit functions, and then of course we have this differentiation using trigonometric substitution. So they compile all this in just one exercise. So but what I'm going to do here is we're going to make this into different sections, and then maybe in the last we can just uh, solve the whole exercise as a whole. So here of course generally I'll be using my own, not mine, but examples just to make you understand from different books. So we are going to make three videos, that is derivatives of inverse trigonometric functions, derivatives of implicit functions, and derivative of the functions using trigonometric substitutions. Alright, so it's going to be short videos, three videos. Then maybe in the fourth video we will just compile and then solve the entire exercise. Okay, that's going to be a good exercise for you also. So of course this is the derivative of the inverse trigonometric functions. I believe that all of you may have the formulas with you, and then of course not forgetting the domain and range, because you have already studied what are inverse trigonometric functions. So what will be the domain for x here? Domain for x of course would be what? Minus 1 to 1, isn't it? Because we know that square root of a negative value is not defined, and then we cannot have 1 by 0 for the domain. So that's why it has to be minus, it should belong to, the value of x should be within minus 1 and plus 1, isn't it? So alright, I'm going to be discussing, because we're not discussing about functions here. So let's just quickly solve one. But of course, yes, this is just a formula, but don't forget, here class 11, as we discussed earlier, it's about what? Chain rule. So questions will be based on chain rule. So let's just start the questions directly. That is y equal to, let's say, tan inverse root of x. Tan inverse root over of x. So what was the formula derivative for tan inverse x? Okay, now differentiating both sides, what do I have? What was the derivative of tan inverse x? Derivative of tan inverse x is 1 by 1 plus x squared. But again, not forgetting the chain rule. What is the value of x here? That is, since I've already discussed, now I believe that you have learned, so we're just going to continue. That is x squared, but we know that this is not x, isn't it? This is not x, so we will have to continue with our chain rule, because we have two functions, so we have to continue with derivative of root over of x. So that's going to be 1 by 1 plus x squared. This one I already gave you a tip on that in the previous videos. Derivative of root over of x is simply 1 by 2 root of x. So that's all. You can just leave it there. No need to just arrange too many things and all. I think that should be more than enough. Alright, not squared, this is going to be x. Okay, so alright, so moving on to another question. Let's try some more questions. That is now okay, this is going to be good. So that is root over of cot inverse root of x. Question number 2. Root over of cot inverse root of x. Okay, so let's differentiate this. So differentiating both sides with respect to x, that's going to be derivative of root over of cot inverse root x. Did you identify how many functions do we have here? 1, 2 and 3. So chain rule will come 3 times. So first, derivative of root x. What is it? What did I say? 1 by 2 root of x. So 1 by 2 root of x. Cot inverse root x into derivative of the second function, that is cot inverse root of x. So that's 1 by 2 root of cot inverse root x into derivative of cot inverse root x is 1 by 1 plus x the whole square. So finally the third function, derivative of root x. Okay, so that's going to be, I'm just going to arrange in, right? This function first, x, the second, 2 cot inverse root x into, what is the derivative of root x? Again, 1 by 2 root of x. So maybe 1 by 2 to the 4 root x 1 plus x cot inverse root x whole root. Alright, so that's going to be the solution for root over of cot inverse root x 1 plus x root x. Okay, so this was okay, fine. Another question would be number 3, that is, let's say let y equal to e power tan inverse root x, e power tan inverse root. Okay, since we're already doing so many questions on tan inverse and all, let's try this question, that is root over of differentiate. Alright, no problem, this question also can be good, that is differentiate root over of 1 minus x square, root over 1 minus x square into sine inverse x, sine inverse x minus x. So this is going to give you good practice, so let's begin. So I'll start differentiating. So first part, so that is derivative of root over of 1 minus x square into sine inverse x. So this is already a product rule that we have to apply, derivative of x with respect to x. So now applying the product rule, that is root over of 1 minus x square derivative of sine inverse x plus sine inverse x derivative of root over of 1 minus x square minus this value 1. So root over of 1 minus x square into, what is the derivative of sine inverse x? The formula root over 1 by root over of 1 minus x square plus sine inverse x, what is the derivative of root x? 1 by 2 root of x. We have two functions here, that is we have to continue with our chain rule, 1 minus x square minus 1. So this value done, so we have only 1 plus sine inverse x by 2 root of 1 minus x square into, this is going to be 0 minus 2x minus 1. I think that's fine. So plus 1 minus 1. So that's going to be minus 2x sine inverse x 2 root of 1 minus x squared. So this is derivative of y with respect to x. I guess that's fine. So 2 equates, so ultimately what do we have? Minus x sine inverse x root over of 1 minus x squared. Is that clear? Okay, so these are some problems. Okay, let's try another question, that is okay, let's try another big question. These are just practice questions. If y is equal to 2x tan inverse x, twice x tan inverse x minus log of 1 plus x squared, log of 1 plus x squared. So let's try to differentiate this. So you can begin differentiating both sides with respect to x. You can continue and just clarify for me. Verify, of course, that's going to be 2. So I'm going to write 2 common out. This is product function. So x into derivative of tan inverse x plus tan inverse x derivative of x minus, okay, derivative of log of 1 plus x squared. So that's twice x into derivative of tan inverse x, 1 by 1 plus x square plus tan inverse x into 1 minus, what was log of x? It was 1 by x, so 1 by x. But we have two functions, so chain rule follows that because it's not x, the value of x is 1 plus x square. So twice x upon 1 plus x square plus tan inverse x minus 1 by 1 upon x square, so 0 plus 2x. Alright, so 2x, okay, let me just write above, that's fine here. So twice x, 1 plus x square plus twice of tan inverse x minus twice x, 1 plus x square. So that's done, that's done. That's simply twice of tan inverse derivative of the function given, that is simply twice of tan inverse of x. Alright, so that's why that's how we are going to be doing some basic two more videos. Okay, two more videos, small videos. So this was about inverse trigonometric functions and how to use them. Of course, definitely with chain rule. Then in the next video we will learn about maybe some questions on differentiation using trigonometric substitutions. Then another one that is about implicit functions. And after that we will solve exercise 5.3, complete wipeout. Okay, so fine, then I hope you have learned the basic things, what's coming ahead of us. So looking forward again to seeing you. Alright, so please don't forget to share and subscribe, more importantly, and of course like. Till then, take care, bye bye.